Sometimes we're going to choose to use horizontal rectangles instead of vertical rectangles. Suppose I want the area bounded by the two curves, y equals x minus 1, and y squared is 3 minus x. Well, if I want to integrate the area, you might think it's just the integral of the area from -1. It's going to be the integral from -1 to 3 of my differential area, if we do it in dx. Now the problem with doing that is from -1 to 2, x minus 1 is my top function, and y equals minus the square root of 3 minus x is my bottom function. So let's call that a1. And from 2 to 3, y equals the square root of 3 minus x is my top function, and y equals minus the square root of 3x is my bottom function. So that's a2. So if I were to do this, I would need to break it up, the integral from -1 to 2 of x minus 1 minus a negative square root of 3 minus x dx plus the integral from 2 to 3 of the square root of 3 minus x minus a negative square root of 3 minus x dx, okay? Because you always want to find delta A is, for when we're doing delta x, it's your top function minus bottom function times delta x, all right, because that's the area of this representative rectangle. Let's instead solve these as x equals a function of y, and I use the term function very carefully. Now, the first thing I'm going to want to do is solve this to see where does x equal x. So where does 3 minus y squared equal y plus 1? And when I do this, what does my function become? It becomes y squared plus y minus 2 equals 0. And so when I factor this, I get y plus 2 times y minus 1 equals 0. So my limits of integration are -2 to 1. So I draw my curves and I put in my representative rectangle. Now, this is the height of my rectangle. So let me do this in blue. The height of the rectangle is right, GHT, can't spell here. Let's do right minus left, okay? So that's my differential height, all right? So the height of this rectangle is, the right one is 3 minus y squared. The left one is y plus 1. So when I solve this down, I get 2 minus y squared minus y. So my differential area is the height times delta y, and the height is 2 minus y squared minus y times delta y. And so the area is going to be the integral from a to b of delta a dy. So this becomes the integral from -2 to 1, let me extend my page here, of 2 minus y squared minus y dy. So now this is 2y minus y cubed over 3 minus y squared over 2, all evaluated at -2 and 1. So now for my first term, I'm going to factor this. This is 2 times 1 minus a -2 minus 1/3 times 1 cubed minus negative 2 cubed minus 1/2 times 1 squared minus negative 2 squared. And when I multiply all of this out, I get a nice neat answer of 9/2.